Hi. Well, let's move on to power of indices, the beauty of indices and numbers, and the concept that we've learned on prime factorization. Well, if you look at some numbers, like for example, 32, and when I write like that, what does it mean? The fifth root of 32. Let's interpret this sum. It can be written as 32, and when you write it as a root, you put it as 1 upon 5. The root is the denominator of the fraction. Now 32, if we do a prime factorization, if we have forgotten the numbers, we said, hey, 32, who are you? You divide it by 2, you get 1, 6. Divide it again, you get an 8. Divide it, you get a 4. Dividing it further, you get 32 to be 2 to the power of 5. Now fit that in, 32, here 2 to the power of 5 times a 1/5. As I said, power. AM times N. Do you remember that law? You get an AMN. Power. 5 times 1/5, you get a 1. So 2 to the power 1, the answer is 2. So that's what you get. Look at 81. What is 81? Yes, 3 to the power of 4. And here we write the fourth root of it. So we write it as 3 to the power of 4 times 1/4 power. We get a 3. Amazing, isn't it? The root. Now let's look at the cube root of 27. That should be really easy. You write it as 27 to the power of 1/3. And 27 is 3 cubed. Yeah. And you have a 1/3 power, that gives you a 3. When we have two numbers, a product of two numbers, in roots, we can break them up. We can say that this is a cube root of 27 times a cube root of 1000. And we can say that 27, here 2 cubed, and it's a 1/3 outside, and 1000, not all the time. We need to go back to prime numbers. We know 1000 is 10 cubed. If numbers are easy, we can also use composite numbers as and when it helps. So 1000 is 10 cubed. Write it out. And the cube root here is 1/3. 3 times 1/3 is 1. So you get 2 to the power 1. 3 times 1/3 is 1. 2 times 10, the answer is 20. So we used indices, the powers of factorization, and looking at it, we got the answer without the calculator. Now I've told you the power of the human brain, the application of knowledge, and how maths strengthens your calculation, the power of learning some things, basic timetables, and the importance of understanding simple basic concepts of prime numbers, composite numbers, prime factorization, and relating them to indices. What is 343? First thing, we look at 343. Does it end with an even number? No. So it's not divisible by 2, 4, 6, 8. No way. And if you look at it, can we divide by 3? How do you test if a number is divisible by 3? You add the numbers up. 3 plus 4, 7. 7 plus 3, 10. The sum of the digits, if it is not divisible by 3, the number is not divisible by 3. Let's see, if you divide by 3, you get a 1. Here you get a 1, you carry it. 13 can never divide by 3. So we look at 5 is out. the last number is not a 0 or a 5. And the number looks like 7. 7 times 4 is 28. 34 minus 28 is 6. You get a 9. 49 divided, you get 7. And here you get 1. So 343 is 7 the power of 3. And the cube root of it multiplied by 1/3, you get a 7. That's your answer. Now, what is 125? Cube root. 125, if you break it down, is 5 cubed. And so we can replace this and put it as 5 cubed. And here is 1/3. Power, you multiply them up, you get 5. The cube root of 125 is a 5. Now, similarly, look at this number. Using the laws of indices, how do we solve it? Is it very challenging? Not that you know it right now. We can break this 125 to be 5 cubed, and you have a power rule. Do not get disturbed about the negative number. Just go ahead and multiply. A plus times a minus will give us a minus. And the 3, you can cancel this off. You get a 5, the power of a minus 2. Remember what we did the other time, the laws of indices? A, the power of minus n, is 1 over an, the power. Apply this law. 5, the power of minus 2, is 1 upon 5 squared. And that answer is 1 upon 25. 5 squared is 25. We've got that. Right? Now look at this. 625. If we use prime factorization like what we did earlier on, and you break it down, try it out. Did you get 625 to be 5 to the power of 4? Very good. So 625 is 5 to the power of 4. And here we have a little power here, which is minus 0.25. So you're multiplying. What is minus 0.25? 0.25 is 1/4, right? So change this decimal to a fraction, and this is actually a minus 1/4. And outside, you have a minus 2. Do not panic. Do it step by step. Well, when you multiply 4 by minus 1/4, you could cancel it off. You get a minus 1. A minus 1 times a minus 2. A minus and a minus. When you multiply, you get a plus, don't you? 1 times 2, 2. So your answer is 5 squared. Minus 1 times minus 2, a plus 2. 5 squared is a 25. So that's how you get this answer. Please look at it. Let me go through again one more time. 625 to the power of minus 0.25 times minus 2. Well, I did it step by step. I first broke it 625 to prime factorization. And 625 is none other than 5 to the power of 4. And a minus 0.25 is a minus 1/4. And here we have a minus 2. They're all a series of powers. Well, let's multiply them all. 4 times minus 1/4, you cancel, you get a minus 1. A minus 1 times a minus 2, you get a 2. And 5 to the power of 2 is 625. Sorry, 5 to the power of 2 is 25. Right? Have you been alert? Great. Now you can try it out on your calculator. Sometimes your fingers may slip and your calculator, you may not get the right answer too. So let's use the human brain. Let's use the brain get your answer, you feel a sense of victory. Look at 81. Is this manageable? What is 81? If you do a prime factorization, a quick one, you get 2. 2 times 3 is 6. The remainder is 2. 21 divided by 3 is a 7. Divide again by 3, you get a 9. Divide by 3, you get a 3. Divide by 3, you get 1. 81 is 3 to the power of 4. And if you look at minus 0.25, 0.25 is 1 quarter. So here you get a minus 1 quarter. When you multiply, cancel the powers to get them. 4 times minus 1 quarter. You get 3 to the power minus 1. What does that mean? Remember the laws of indices. When you have a negative, it's 1 upon an, 1 upon 3. That's your answer. You got it. How about doing this? Sometimes we can go right into it. We can multiply these two together. Power, power. It will still give you the same answer. You can go this way step by step and then move out. Or we can do here. 81 minus 0.25 times 2 is a minus 0.5. And what is 81? We know 81 is 3 to the power of 4. And we have a minus 0.5 is a half. Cancel it. You get 3 to the power of 2 times minus 1 is 3 to the power of minus 2. And what does that give you? Laws of indices. 1 over 3 squared. That's 1 over 9. Yeah, you got it. Because this is 3 to the power minus 2. 1 upon 3 squared. 3 squared is 9. That's how you get that. Now let's look at this. This is pretty simple. I know you know it. Let's find out if you got this right. 16 is 2 to the power of 4. 0.75. If you leave it as a decimal, you got to multiply 4 times 0.75. But we know that 0.75 is 3 quarters, right? Multiply them, you get 2 cubed, and 2 cubed is 8. Great. Never ever say that 2 cubed is 6. Well, by now you know it. 2 to the power of 3 is not 2 times 3, right? 2 to the power of 3 is 2 times 2 times 2. Gentle reminders. Now we look at this again. When we see a power, it looks, one look, it frightens anyone. You want to run away from it. Ooh, oh my God. But now that you know indices, isn't it so easy? Let's do it. Got it? 16. Now what is this? Minus 3 quarters. And what's that? Minus 1/3. Power. You're multiplying. Minus times minus is a plus. You could cancel the 3 off. And what you get? 16. Minus times minus is a plus. This is a 1. 1 over 4. What is 16? 16 is 2 to the power of 4 multiplied by 1 quarter. Cancel them. Ooh, the answer is 2. Would you ever thought of this answer when you looked at it? That was going to give you such an easy answer. It's because of the laws of indices that makes maths, numbers like this, very easy. Practice more and you'll get it.